Hello, it's Miss Huser, and I'm from 8 Silver, so here we go with lesson 13. So we're doing some more solutions to linear equations. So in order for it to be a solution, it has to be on the line, okay? So make sure we are aware of that. Alright, so down here, okay. It says, for each equation, choose a value for x, then solve for the corresponding y value. That would then make this statement true. So I'm going to plug in something for x and then solve for y. So we can pick whatever numbers we want. So let's just do x equals 2 for this first one. So that means I'm going to plug in 2 for x and then solve for y. So I'm going to have 6 times 2. I'm plugging the 2 in for x, so that's where it's written that way. And this is equal to 7y. Now if I take 6 times 2, I get 12, 7y. So I need to get y by itself, so I need to see how it's connected to that other variable, which is 7. So in order to get y by itself, I have to disconnect it from that 7. And so I need to first see how y and 7 are connected. And it says y times 7 there. So in order to undo that, I have to do the opposite of multiplication, which is division. So I'm going to divide both sides by 7, and I get 12 over 7 as my answer there. So I'm going to go ahead and write this as a coordinate. 12 over 7. Those are my x and y values there. Alright. So I'm going to do the second one. I'm just going to do it in a different color. And let's use 1. Okay, so I'm going to plug in 1 for x. So 5 times 1, because that's where the x was, plus 3y equals 9. Alright, so I'm going to go ahead and multiply these together, and I get 5 plus 3y equals 9. Alright, so first I need to get rid of this 5, so then I can focus in on that 3y. So I'm going to subtract to get it away from both sides, because this is a positive 5, so in order to get rid of it on that side, I have to then subtract, because 5 minus 5 would then be 0. So then I get 3y equals 4. Once again, we're multiplying, so to undo that, I have to divide, and I get 3 divided by 3 on both sides, and I have y equals 4 over 3 is my final answer. So when x is 1, my y is 4 over 3. I think I said y. Okay, now at the bottom here, let's look at where x is. So x is connected to that 1/3. Well, we have a fraction here, so let's think of a nice number that would then cancel the fraction out, so then we'd have a whole number, okay? So we have a 3 in the denominator, so I need to use a number that's divisible by 3. Okay, so I could do 3, 6, 9, 12, whatever. Let's just stick with 3 for now. So I'm going to have x equals 3. So I'm going to plug that in for x. So I'm going to have y plus 5 minus 1/3 times 3 equals 7. Plugging that in for where that x was. So now I'm going to do the multiplication over here. So if I have 1/3 times 3, it's the same as having 3 over 1. So I'm going to put them both as a fraction to help me out here. So I'm going to multiply across, and I get 3 on top and 3 on the bottom. Well, what's 3 divided by 3? It's 1. So 1 would be my answer there. So now I have y plus 5 minus 1 equals 7. Well, I need to combine these here, so then I can simplify. So 5 minus 1 gives me 4, so y plus 4 equals 7. Alright, how is y connected to that 4? It's connected through addition, so I need to subtract to get rid of it on that side. So now I have y equals 3. So if I were to write this as a coordinate pair, I would have when x is 3, y is 3. And there we go. Alright, so now in this next activity, we are going to have some statements and see if they are true or false. And we're going to look at this graph to determine that. Okay, so here's 3 lines. Line N, M, and L. That probably didn't help. But there we go. So there are the 3 lines that we will be referring to. So this number 1 says is 4, 0 is a solution of the equation for line M. So for that to be true, we need to go see if this point lands on line M. Okay? So we had point 4, 0. So my 4, 0. So my x value is 4. So I go 4, and then my y is 0. So that is my point. Now if I look at line M here, does that go through the point I just plotted? No. So, alright, so if I come over here, is it a solution? No. This would be false. And that's because it doesn't land on line M. Alright, so then next it says, the coordinates of point G make both the equation for line M and the equation for line N true. So in order for that to be true, point G needs to be on both of those lines. So let's go check that out. Now point G is right here. So line N does go through it, so that's good. And line M goes through point G as well. So this would be true. And the reasoning for that is it lands on both lines. Okay, so now it says x equals 0 is a solution of the equation for line N. So let's go see that. So if x equals 0, that means my line would then be going through the x-axis at 0. So this is what my line would be for x equals 0. Alright, so if I look at line N, it does cross through that line at that point. But at this point, our coordinates would actually be 0, 0. So this one's a bit tricky, but it's saying, but the solution right here, that point that lands on the line, would be 0, 0. It would not be just x equals 0. And so this would be false. And it's because we need a pair. So we need a coordinate pair. So we need that pair of points. So x equals 0. That is a whole different line. That's not a point, okay? So that is why that one doesn't work, okay? So now it says 2, 0 makes the equation for line M and the equation for line N true. So that point needs to go through both of those lines. So let's check that out. I'm going to erase this. So let me double check what my point is. Okay, so it would be 2, 0. This would be my point there. Now, does that go through any line? No. So it doesn't go through any line. So we know it can't be true for this because it doesn't go through any line, and our statement says it goes through 2. So false. Because it doesn't go through either line there. Alright, now there is no solution for the equation for line L that has y equals 0. Alright, so let's go ahead and do that. Alright, so if our line is y equals 0, that means my line hits the y-axis at 0, which would be the x-axis there. So we're focused on line L. So we're seeing, does line L ever hit a point where the y-coordinate would be 0? Well, let's trace it out. And here we go. Eventually, if I were to extend this line, it would hit a point, and I don't know what the x value would be there, but that y-coordinate would be 0. So this would be false because there would be a solution. So we found the point that it would eventually hit. Let's hit x-axis. There we go. Now it says the coordinates of point H are solutions to the equation for line L. So let's see if it goes to line L. Alright, so let's find point H. And it lands on line L there. So this would then be true. And the only explanation we have to put is that it lands on the line. Okay, it says there are exactly 2 solutions of the equation for line L. Alright, well, we don't really necessarily need to look back at that, but any solution, any point on this line would be a solution. So all of those dots I'm attempting to make there are solutions for line L. So I just plotted more than one point. So that means that this statement is false, okay? Because we could have an infinite amount of points on that line, okay? So, and each point is a solution. So, infinite. So, because we could have infinite solutions there, okay? Now it says there is a point whose coordinates make the equation for all lines true. So let's go see if there's a point that all 3 lines go through. Okay, so here we go. I'm just going to color code them. And if I look here, well, I only see blue and red. Here I only see blue and green, and over here I only see green and red. So at the points where they intersect, I do not see all 3 colors. So, false. No points where they all intersect. All right. Okay. And that's about it. Make sure you read through the summaries. It helps get a nice understanding of what the main goal is of the lesson. But that is the last lesson for the unit. So congrats, you survived Unit 3. All right. Yeah, that's all for today.